So now let's talk about the XtremIO specifications, kind of, how big, how fast, what do you get, that sort of thing. So first, it is currently available in two size configurations. This is what is known as the 10 terabyte brick and the 20 terabyte brick. So the 10 and the 20 are raw capacity, meaning total capacity before it's formatted, before resiliency overheads taken out, anything like that. So the 10 terabyte brick gives you 7.5 terabyte usable. It is 10 terabyte because it is 25 SSDs, 400 gig each, and that's 10 terabyte. The 20 terabyte brick is literally double that. It is 25 800 gigabyte SSDs. So 25 times 800 gives you 20 terabyte, but you get a usable capacity of around 15 terabyte. So keep that in mind again as you start to size and scale. Larger sizes are coming. SSDs are continuing to, get larger, obviously, and I think we'll see those continue to be put in there. So if you want larger capacity without buying multiple bricks, you'll be able to do that. There is talk of, say, 40 terabyte when the 1.6 terabyte SSDs are released, and I'm sure we'll go up and up and up from there. One thing to keep in mind is sizing is really based on total capacity, pretty much. What I mean by that is if you take a 10 terabyte brick and you take a 20 terabyte brick and you run benchmarks against them, your numbers are going to be the same. The number of IOPS that you get is dictated by, usually roughly by the number of SSDs that you have. Sometimes larger SSDs are a little quicker, depends how they're built, but really it's not enough to make a big difference. So a 10 terabyte and a 20 terabyte brick will give you the same performance. So if you need 100,000 IOPS, and you need, X amount of capacity, that basically dictates which size brick you start with. So it does make sizing fairly simple. But if you need more throughput, then you would add additional bricks for more I/O, as well as more capacity if you needed it. So we'll talk about I/O numbers here in a second, but the first sizing guideline is the total capacity, and really it's the usable capacity. You can also stack bricks to increase capacity and performance. Again, this is that scale out model we've been talking about. So if you need more, you start off buying a 10 terabyte brick, you start to run out of space, you can buy a second one, you can go to 4, and you can just keep adding. Or if you start running out of IOPS, you can add another brick to your cluster, and again, you'll double your performance going from 1 to 2 with that linear scaling. Right now, you can do up to 4 bricks. 1, 2, or 4. 3 is not currently supported. Hopefully in the future we'll go up above that. There's been discussion of going to 8 or even more, but that's kind of later on down the road and not guaranteed just yet. But it is something to kind of keep in mind as you start planning out when you purchase your first, and then you're thinking about when you need to expand beyond that. One other note, if you start with a 10 terabyte brick, you cannot then add a 20 terabyte brick to the cluster. You can only scale by adding the same size bricks. This starts to make sense. We'll talk about how XtremIO works, about how the content engine works, and you'll see some of why this is like that due to balancing issues of the bricks in the cluster. But it's also something to keep in mind when you start planning out what your implementation is going to look like and how you're going to grow. Specifications, the big list of numbers. So let's go through this. First of all, physical size. The first brick is 6U. The second brick is 5U, 6U of rack space, 5U of rack space. The first brick has some extra stuff in it, so it'll add more, it'll need a little bit more space. Total about 750 watts. That'll obviously depend on things like load and sizing, but around 750 watts. It's high available. We've talked about the dual active storage processors or controllers before. You have 2 of those, and they're always active. Host access, active, and host ports. So for a cluster, you get a total of 4 8 gig fiber channel ports or 4 10 gig iSCSI ports. If you look on the back of your controllers, you'll see 2 8 gig and 2 8 gig and 2 10 gig iSCSIs, but you'll get a total of 4 and 4 in the cluster. Then you have functional IOP performance. So this is, we'll get into this in a bit of discussion, but really, EMC is big on real world numbers, meaning there's a term that's used in the industry called hero benchmarks. Hero benchmarks are like tuning the benchmarking tool to give you the best numbers. Wow, that is insanely great numbers, but it is not real world applicable. What EMC is doing here is they're trying to make these real world numbers. So what they do is they first fill the array up, make sure all cells within the SSDs have been written to. They make sure that the array is close to full, like 80%, and then they run their benchmarks. So this is kind of what you would consider to be almost worst case scenario. I like this because it is like, what's my array going to do a year or two from now? A lot of all-flash arrays are fast on day one. It's that day 730, 2 years later, that you really need to be worried about. So knowing that, what EMC has done is they've released their numbers. So we'll start at the bottom, the worst case. SSD's write performance is normally worse than read, especially after they've been written to. So 100% write is 100,000 IOPS, which is a fantastically good number. 100% read is 250,000 IOPS. Again, reads are faster than writes. Then you have kind of this mixed workload, 50% read, 50% write, fully random. So this is kind of a little bit closer to what the real world is going to see of a mixed workload. And you still get 150,000 fully random. And the latency, as we see there, is less than 1 millisecond. So very high performance. If you're relatively new to storage, these are big numbers. When we build traditional arrays with spinning disks, to get 250,000 IOPS is a task. It takes a lot of design work, sizing, architecture. You have to really go through and think about what you're doing. With something like this, you just throw a brick in there, set it up, point your host to it, and off you go. So very good numbers. Again, latency is less than a millisecond, which is just amazing. Again, high performance spinning disk arrays will be 5 or less. You'll start hitting performance issues at 20 or 30 millisecond. But this thing, even doing 150,000 fully random mixed IOPS, will give you less than a millisecond of latency. And it's funny because some of the original code running on here for the interface for the XMS actually showed you latencies in millisecond, and it was useless. It was useless because it would be 1 or 0. That's all it ever show you. So now, if you look in there, it does it in microseconds to at least give you an idea. But you'll always have latency under a millisecond unless you're just hammering these boxes and really taking them outside of their design, which means you need to expand your cluster. Then the flash type is eMLC. There are several different types of SSD and NAND flash. The cheapest and most common is MLC, multi-layer cell. This is what you'll normally see in desktops, what you'll normally see in some other flash arrays. And you see it because it's it's not inexpensive, but it's the least expensive form of NAND flash. Then you have the high end, which is SLC, single layer cell. It's higher performance and has a longer life than MLC. So you have to keep life in mind on SSDs. SLC you can write to it a lot more. You can write to those cells a lot more than MLC before you wear them out. So that's another reason that SLC costs more. It just also costs more to manufacture. So why don't we see SLC everywhere? It's just too expensive. It costs too much money. So what you see now is this mix, this kind of I won't call it a hybrid, but it's kind of a compromise. eMLC, Enterprise MLC. It still uses multi-level cell technology, but there are some other things that it does to extend the life of the drives. So this is what XtremIO uses. eMLC is common in, say, in server flash. If you do something like VMware vSAN or server-side caching, often it'll be recommended to buy eMLC drives because regular MLCs, that'll just wear them down too quickly. So just something to note that XtremIO does use eMLC. And then usable capacity, we just talked about this. On the current shipping bricks, it's 7.5 and 15 terabyte. But you add on top of that deduplication, and you'll get even more usable capacity than what you get there.